This is the Unit 3 summative test review. What we'll do in this video is I'm going to go over one problem in each row. So the first column I will go over for you. You are then responsible for completing day 1 practice in class and then day 2 practice on your remote day on Wednesday. This should help you prepare for your Unit 3 summative that will be in class on Thursday, February 4th. The first section that will be on your summative was 3-3 using function notation. We want to evaluate for the following functions. We're given an f function and a g function. For number 1, we want to find the value when x equals -6 for the f function. So we want to substitute the value of x equals -6 into the f function. So now we want to multiply -5/3 times 6. We can multiply the numerators and the denominators, or we can cross cancel. 6/3 is 2/1, which means -5/3 times -6 is +10. So 10 plus 10 is 20, making the value of the function when x equals -6 equal to 20. So f of -6 equals 20. For number 4, we want to use the same function. We want to use the f function. And this time we want to find the value of x when the function equals 20. So we're going to take the function and this time set it equal to 20 and solve for x. So first we want to subtract 10 from both sides. From here, you can split this up into 2 steps, multiply both sides by the denominator, and then divide by -5, or you can just multiply both sides by the reciprocal. Now we want to multiply 10 times -3/5. Again, you can multiply the numerators, -30, and multiply the denominators, +5, and then simplify, or you can cross cancel. 10/5 is 2/1, and 2 times -3 is equal to -6. So f of -6 equals 20. I made a little mistake when making this review because I realized I used the value when f equals -6 for number 4 as well, but at least you saw the steps when we're given an x value and when the function is equal to something. Okay, so the value inside the parentheses represents the x. If it's equal to, you set the function equal to that number. The next section we did was 3-4, graphing using x and y intercepts. We want to find the x and y intercepts and express them as an ordered pair. The x-intercept is the value of x when y equals 0, whereas the y-intercept is the value of y when x equals 0. So we want to substitute y equals 0 into the equation, so that whole term is going to become 0 because 0 times anything is 0. And solve for x. Divide both sides by -2. We get x equals -8, making the x-intercept the point -8, 0. For the y-intercept, we're going to substitute x equals 0. And solve for y. So now we want to divide both sides by 4. And we get y equals 4. So that would be the ordered pair 0, 4. Then we took it one step further and we found the x and y intercepts, and then we graphed using only those 2 points. So first we want to find the x-intercept. So we're going to substitute in y equals 0. Now we want to solve this equation for x, so we're going to divide both sides by 3. And we get x equals -4, which makes the x-intercept -4, 0. The key thing is when you're looking for the x-intercept, you want to make sure your equation you have an x variable to solve for. If you don't, that means you probably substituted 0 in for the wrong variable. So -4, 0 is our x-intercept. So let's go ahead and graph that point on the graph below. -4, 0 is on the x-axis at the point -4, 0. Now let's find the y-intercept. So we're going to substitute x equals 0. Careful not to lose that negative sign in front of the 4. So we have -4y equals -12. And then solve for y. So y equals 3, which is the ordered pair 0, 3. So then we're going to graph that point. So that is on the y-axis, where x equals 0 and y equals 3. So our graph is only going to have those 2 clear points. Once we have those points graphed, we want to connect and extend with arrows. The next thing we learned was graphing vertical and horizontal lines. With 13, we have to first solve for that one variable. So we want to solve for x. To do so, we're going to divide both sides by 3. So we get x equals -3. So first, plot the point where x equals -3. Now x also equals -3 at this point here, at the point -3, 1, -3, 2, -3, 3, -3, 4, and -3, 5. X also equals -3 at -3, -1, -3, -2, -3, -3, -3, -4, -3, -5, and so on. So the line x equals -3 is a vertical line through the point -3, 0. Whereas y equals would be a horizontal line. The next thing we worked on was finding the slope of a line. So I like to first determine the sign of the slope. Is it an increasing line with a positive slope or a decreasing line with a negative slope? This line is increasing, so we're going to get a positive slope. We want to find the rise over run from one point to the other. So from one point, I move up 4 and to the right 2. So m equals 4 over 2, which we can reduce to 2 over 1. Always reduce the slope whenever possible. We want to have a simplified fraction. Then we learned how to graph linear equations in slope-intercept form. So we have y equals -3/2 x plus 1, which makes the slope -3 over 2. The y-intercept is at 1, which is at the point 0, 1. We want to graph that point first at 0, 1. Now we want to graph a line with a negative slope, so we want our line to end up to be decreasing. So from the y-intercept, we are going to move up 3 into the left 2. I'm going to use the orange to show the directions, but the orange is not part of the graph. So from the y-intercept, we can go up 3 to the left 2 and make that point. From the y-intercept, we can also move down 3 to the right 2. And we can do that again, down 3, right 2. That's as many points as we can fit, so we're ready to graph our line and extend with arrows. Once you're done graphing, just make sure that the line you graphed has the right sign slope. We graphed a decreasing line and the slope is in fact negative. Your test isn't going to be very long, so we want to make sure we don't make small mistakes throughout. And sometimes those quick checks just help make sure everything is right. The next thing we worked on was graphing equations in slope-intercept form, but when the equations were not in slope-intercept form yet. So we want to solve these equations for y first. The first step is to always add or subtract the x term. In the case of number 22, the x term is negative, so we're going to add it to both sides first. When we rewrite, we want to write the x term first on the right. So I'm left with positive 3y on the left equals 2x minus 6. If this was a minus, we'd want to make sure that we brought down a negative sign, but it's not, so we don't need to. Now we want to divide each term by 3 to solve for y. So I get y equals 2/3 x minus 2. In this equation, the slope is 2 over 3, and the y-intercept is at -2, which is going to be at the point 0, -2. So now we're ready to graph. Because we can graph this using slope-intercept form because it's now in slope-intercept form. So we want to plot the point at 0, -2. Always start on the y-axis when we're graphing in slope-intercept form. Now this time I'm graphing a positive slope. So I want to graph an increasing line. To graph a positive slope, positive 2 over 3, I'm going to move up 2 to the right 3. Again, I'm going to use the orange to show my directions, but the orange is not part of the line. So from the y-intercept, move up 2 to the right 3 and make that point. Up 2 to the right 3. From the y-intercept, we need to also move down 2 to the left 3 to be able to graph as many points as we can. Down 2 to the right 3. Now we're ready to connect and extend with arrows. Again, just do a quick check. Our line is an increasing line with a positive slope, and our slope in the equation is also positive. The next section we learned was graphing absolute value functions. The form is y equals a times the absolute value of x minus h plus k. Our first step is to find the vertex, which is at the point hk. So the vertex for number 1 is going to be -1, 4, because we're adding inside the absolute value. It's always opposite sign inside, same sign outside. And let's go ahead and graph that point right now. -1, 4. So find where x equals -1 and where y equals 4. Now we want to determine if this graph opens up or down. And we do that by looking at the sign of the a value. The a value is negative, so this graph is going to open down. And the a value is 2. You could also write that as -2, but we've already determined it's negative because it's opening down. And now we're ready to graph. So from the vertex, we're going to graph a slope of 2 over 1 in both directions. We're going to graph the right side of the v first, and then go back to the vertex and graph the left side. So from the vertex, go down 2 over 1. And then go back up to the vertex, and again go down 2 over 1 to graph the left side. There's our v that opens down. So we're ready to connect and extend. I'm going to help you out writing these equations. I'll also help you out writing the equations on the summative. This first problem, which I want you to finish as part of your independent practice, but I'll help you get started. Mary can ride her bike at 10 miles an hour and walk at 4 miles an hour. She needs to get home, which is 20 miles away. We want to write an equation that represents the time riding her bike and the time walking to travel the 20 miles. So because these two variables, the time riding her bike and the time walking, are two similar variables, but they represent different things, we're going to use the standard form equation. We're going to use standard form to write the equation. We use this equation when we have two similar but different variables. So we're going to attach the speed with the variable. So she can walk 10 miles an hour. Sorry, she bikes 10 miles an hour. So 10 miles per hour times the time she bikes plus the 4 miles an hour times the time she walks will equal the distance that we need to travel. You can also think of this as, because the time biking is on the x-axis and the time walking is on the y-axis, you could also use 10x plus 4y equals 20 if that's easier for you. You're going to finish this problem on your own, but I just wanted to help get you started. For number 29, your parents give you $60 to go to the movies with your friends. Tickets cost $8 a piece. This equation represents the amount of money M that you have left over in terms of the number of tickets that you buy. So the reason that the slope is negative, the price of tickets is negative, is because we're spending that amount each time we buy a ticket. So each time we buy a ticket, we'll have $8 less left over. So the domain is always the independent variable, and it also corresponds to the x term. So the domain is the number of tickets, and since you can't buy part of a ticket, the domain is a discrete domain. You have to buy 1 ticket, 2 tickets, 3 tickets, 4 tickets. You can't buy part of a ticket. So because it's a discrete domain, that means our graph is going to be a scatter plot. But we're still going to use the y-intercept and the slope to get each point of the scatter plot. So in that equation, the slope is negative 8/1. And this represents that you're spending $8 per ticket. Which is why it's negative, because you're spending it. The y-intercept is 60, and that represents the amount of money that you start out with. The y-intercept is always the initial amount, whereas the slope is always your rate of change. So the amount of money we have left is changing $8 per 1 ticket. So now let's graph the scatter plot. So we want to graph the y-intercept at 60. Now this scale is a little different. We can't go down 8/1 because the y-axis is increasing by 2. So we're going to go each tick mark represents 2. So if we go down 2, 4, 6, 8, and over 1, we're really going down 4/1. So go down 4/1 and make your next point at the point 152. So go down 4, 1, 2, 3, 4, and over 1. Down 4/1. Down 4/1. Down 4, which is really 2, 4, 6, 8/1. Down 2, 4, 6, 8/1. 2, 4, 6, 8/1. And that's as many points as we can fit on this graph. So let's take a look at this graph. This has a decreasing slope, which makes sense because we are, for every tick, as the tickets increase, the number of tickets that we buy increases, the amount of money we have left decreases. And also, there's a y value for 1 ticket. There's a y value for 2 tickets, 3 tickets, 4 tickets, 5 tickets, 6 tickets, which makes sense because that's how we have to buy tickets. We can buy 1 ticket, 2 tickets, 3 tickets, 4 tickets, 5 tickets, 6 tickets, and it looks like we can buy up to 7 tickets. So the two variables we have number of tickets and the amount of money left. The amount of money we have left depends on the amount of the number of tickets that we buy. So the independent variable represents the number of tickets, whereas the dependent variable is the amount of money we have left. The independent variable always represents the x variable, represents part of the domain, which your input value. It's also usually something that you can count, a quantitative variable. Whereas the dependent variable usually corresponds to the y values, the range, or the output values. And the dependent variable usually has some type of value to it or measure. The last question, we want to find the greatest number of tickets you can buy. If we go back up to the graph, it looks like we can buy up to 7 tickets. And when we buy 7 tickets, we will have $4 left over. So that's it for the teacher example portion of this review. The next step is to work on the second column in class. And then I'd like you to work on the third column on your remote day. You are not going to be submitting this in Canvas. I'm just going to be checking it off for effort before your summative on Thursday. And also the full answer key is posted in Canvas for you to check your progress as you work through this review. You can finish the review and then check, or you can check as you work. However, whatever you would prefer. If you have any questions, please don't hesitate to email me, and I will be in class for the summative on Thursday.